Hello everyone! We are going to be talking about some more Algebra 1 today. And today we're going to solve some equations. This is something I do every day. I solve equations. This is so much fun. So if you go into a science field, you're going to have to probably solve some equations. Just a heads up. And if you love science, you love math, it's going to be a lot of fun. Today we have one goal only. That is to solve equations by using addition and subtraction. So as I always say, let's dive on in. Okay, let's talk about a property. This is the addition property of equality. Okay, so what does this say? It says if the same number is added to each side of an equation, the resulting equation is true. Okay, so basically if you take the same number and you add it to the left side of the equation, assuming you're writing from left to right, on the left side of the equation and on the right side of the equation you add the same exact number, the equation has to remain true. So this is the addition property of equality. Let's look at this mathematically. Let's say that 7 equals 7. Alright, so I'm just going to pick a number out of thin air and I'm going to add it to both sides. So let's do 7 plus 3. Alright, so then we got to do that to the other side. We got to add this plus 3. Plus 3. Okay, so 7 plus 3 and 7 plus 3, we know that's 10 is equal to 10. Hey, it's still true. It is still true. Alright, so let's continue talking here a bit about a definition. And let's say we're looking at the definition of equivalent equations. Okay, what are equivalent equations? So those are equations, assuming that you already know what an equation is, that have the same solution. Okay, all right, let's go ahead and look at some examples of some of the stuff we've been talking about here today. Let's say this is example 1. Let's say we have the equation x minus 3, let's go with minus 1, is equal to 3. Okay, so what we're going to do is we're going to add 1 to each side here. Okay, so if we rewrite this, that's x minus 1 plus 1 is equal to 3 plus 1. Alright, so we know that when we add plus 1 and minus 1, this becomes 0. So therefore, we get x is equal to 3 plus 1, that's 4. Wow, we just solved what x was. Did you see that? Alright, now we want to check to make sure this is true. Okay, we want to perform a check. So how do we do that? Let's plug this 4 back in for x. Okay, so we got 4 minus 1 is equal to 3. So if we do 4 minus 1, that is 3. So 3 equals 3. Ta-da! Great job! We did it! So we added a positive number there to each side, right? Let's look at another example here. Example 2. Let's say that we have 7 plus y is equal to 10. Now, this time, instead of adding a positive number, I want to add a negative number. So in this case, I want to add minus 7. So I want to add minus 7 over here. Okay? So if we get 7 plus minus 7 plus y is equal to 10 plus minus 7. That's a goofy looking y there. Alright, still not much better, but we'll go with it. So 7 plus a minus 7 is basically 7 minus 7. We know something minus itself is 0. Okay? So then we end up with y is equal to 10 plus minus 7. So 10 minus 7 basically is then 3. Interesting. Let's do a check. We want to check if we can spell the word check. Uh-oh. There we are. I did that thing I did once upon a time that I tried to avoid doing. Alright, check. So let's plug in y of 3 in here. So 7 plus 3 is equal to 10. So 7 plus 3 is 10, is equal to 10. Voila! I once knew a guy named Voila. I still know him. It's an interesting name. So if you say voila, you could be actually talking about a person. Alright, let's keep going here. Let's talk about another property. In this case, we have the subtraction property of equality. Woo, those Y's. They are tough for me to draw. Let's try again. Okay, so what is this? Well, it's very similar to the addition property of equality. We're just going to basically say the same thing except replace added with subtracted. So if if the same number is subtracted from each side of an equation, the resulting equation is true. Okay? Well, that's kind of similar to what we did in that last example. Remember, we added a negative number? When you add a negative number, it's kind of like subtracting a positive number. Okay? So let's look at... I have to fix this U. It is bothering me. Alright, let's look at an example here. Oh, we're on the example 3. Look at us go. Alright, so let's say we have 12 plus Z, or Z if you're in America. That is equal to 40. Alright, so what we're going to do is we are going to subtract 12 because we have the variable here, so we have to find the numerical part and subtract that. Minus 12 from each side. So then that gives us 12 minus 12 plus Z is equal to 40 minus 12. Well, if we solve that, 12 minus 12 is 0, so we just left a Z over there. Z is equal to 40 minus 12 is 28. Let's do a check. And I'm not talking about the Czech Republic here. We want to see if this is right. And I'm not talking about those little paper things that people sometimes use nowadays that used to be a lot more common back in my day. So let's check by putting in 28 here for z. So 12 plus 28 is equal to 40. That's the equation we get, right? Because we plugged in z as 28. So that tells us that 12 plus 28, that's 40. That equals 40. Voila! Hey, there's voila again. We did it again. We solved it. We checked it. It all works out. Great job. Okay, so now let's look at another example. We got lots of examples today. This is great. We're doing such a great job. All right, a plus 1 over 3 is equal to 7 over 12. Okay. So, we want to do two things here. Just to prove that we got this down pat, we know what we're doing. We want to solve by adding, then by subtracting. Okay? So the first time that we solve this, we're going to do it by addition. And then the second time we do it, we want to do it by subtraction. Okay? So let's do the adding first. So let's say that we have plus minus 1/3. And we cannot even tell what number that is. 1 over 3. And then we do that to this side as well. Okay? So then we get that a plus 1/3 plus minus 1/3 is equal to, let's go ahead and find the least, let's see, we got 4, okay. So we got 7 over 12 plus a minus 4 over 12, okay? All right, so we know that this goes to 0. Oh, that's not at all what I meant to do there. Yeah, okay. It's not going to behave. All right, so we know that this part here goes to 0. Okay, so then we're left with a is equal to, and then when we add a negative number, it's basically like subtracting. So we got 3 over 12, which we know that's 1 over 4. Great, we did it by addition. Now let's rewrite the equation that we start out with. Well, we don't want to scroll up or we'll forget what it is because my memory is terrible. Okay, a plus 1/3 over is equal to 7 over 12. All right, now we want to do by subtraction. What are we going to subtract here? We'll subtract 1/3 because we're trying to get a by itself. And then we're going to subtract 4/12, which is the same as 1/3 over here. Okay, so what do we have then? A is equal to, nope, I'm jumping the gun here. A plus 1/3 minus 1/3 is equal to 7/12 minus 4/12. All right, so we know that this is going to go to 0. So we got a is equal to 3 over 12, which is equal to 1/4. So we got a is equal to 1/4, and up here we got a is equal to 1/4. Hey, we got the same answer. That means we did something right. All right, let's look at another example here. Example 5. Okay, so we want to write an equation for the problem. All right, I'm going to pause right here and let you know that there is nothing wrong with pausing and rewinding, not rewinding, I'm old. Going back in the video to rewatch things or playing it a little bit slower or watching it multiple times. There's nothing wrong with that. You can do that. I did that plenty while I was learning and watching videos on YouTube. So don't hesitate to pause and go back if you didn't quite understand something before you move on. Because sometimes if you just kind of barely hang on and you keep moving forward, you get totally lost. Sometimes you have to watch it again. There's nothing wrong with that. So keep that in mind. All right, then solve the equation and check it. Okay? So what do we got here? We have a number decreased by 1 is equal to 3. Alright, so that's the written sentence there. So let's put this in mathematical terms here. So we got a number. So we get to choose whatever letter we want because we don't know what number this is. It doesn't say what the number is. So if you ask a girl for her phone number and she doesn't tell you, you don't know what the number is. So it's a variable at that point. So we can choose any variable. We'll choose x. Okay? X is always a pretty good variable. It marks the spot. So x is decreased by 1. Well, what happens when something decreases? It becomes less. So that means in the mathematical world that we are subtracting. So x minus 1, because we're decreasing by 1, is equal to 3. Whoa, we just put that in a mathematical equation here. All right, now let's solve this for x. Let's add plus 1 to each side. So that gives us x minus 1 plus 1 is equal to 3 plus 1. Well, y'all remember this? When you add and subtract the same thing, it becomes 0. Alright, so then x is equal to 4. Whoa, look at that. We solved for it. Wait. Yeah, that's right. I was questioning myself there for a second. Alright, so let's check this. We want to do a check. We want a sanity check, just to make sure that we're doing this right. Sometimes you do question yourself. You just want to make sure you're doing it right. So let's plug in the 4 in here for x. 4 minus 1 is equal to 3. 3 equals 3. Jackpot, we scored. Alright, great job. Let's do another example here. This is example number 6. Whoa, we are getting up there in example problems. Y'all are getting lucky with all these examples we have today. The Great Wall of China was completed. Hey, it got done. And was 2,500 miles long. That's a pretty long wall. I don't know if I've ever seen a wall that long in person. Alright, so before the 1300s, only 1,000 miles were complete. Okay, so only part of it. Now, I don't know how true this is, so y'all can fact check this. And we want to know how much was added later. Great question. So we know that it's 2,500 miles. And then before the 1300s, that's a long time ago. That's over 700 years ago. 1,000 miles was complete. So how much was added since then? So let's put this into an equation. Let's say that we have 1,000 miles plus x in miles. We don't know how many. And it totaled for a total of 2,500 miles. Okay, so we are going to subtract 1,000 miles minus 1,000 miles. Alright, so then x in miles is equal to 1,500 miles. So x is 1,500 miles. Great job. Alright, let's look at some problems. Problems. Everyone has problems. Alright, let's say that we have a rectangle. Okay. And you get to see my art skills, which are not that great, but we are going to try. Okay, so let's say that this side is 8 meters long. This side is 4 meters long. This side is x minus 5 meters long. And this side is y minus 7 meters long. Alright. So part A of this problem, we want to write, that's not really a W. We want to write an equation to solve for x and then solve for x. Okay, we get to put this in equation form. Alright, so what do we remember about rectangles? The opposite sides, this side and this side, are equal in length. And then these opposite sides are also equal in length. Okay? So we know that 8 meters is equal to x minus 5 meters. So let's put this into an equation. Let's say that we have x minus 5 meters is equal to 8 meters. So x in meters minus 5 meters is equal to 8 meters. Okay, let's add 5 meters to each side. And if we do that, we find out that x is equal to 13 meters. Interesting. Very interesting. Alright, let's look at part B. Part B. We want to write an equation to solve for y and then solve for y. Okay, let's try this. Let's go back up here and look at our figure. So we know that 4 meters is equal to y minus 7 meters. So 4 meters is equal to y minus 7 meters. If we want to rewrite this, we could say 4 meters is equal to y in meters minus 7 meters. So since this is a minus, let's add 7 meters to each side. And we have 11 meters is equal to y. I don't think that looks like an M. Okay, that's a little better. Alright, so we found out that x is 13 meters and y is 11 meters. So if we were to go up here and we said 13 minus 5, we would get 8. So then 8 is equal to 8. And then if we say 4 is equal to 11 minus 7, we get that 4 is equal to 4. Great job. Let's look at one last problem. Alright, so here's my art skills again. Oh, like that looks like a spider web. So let's imagine that it is a great pyramid. Okay. And this great pyramid actually used to be taller. Okay. So nowadays, this great pyramid is 450 feet. And this great pyramid used to be 481 feet. Okay. So what are we to do? We want to write an equation to represent the situation. So we know that the total height used to be 481 feet. And now there is a difference here of d in feet. So d plus 450 feet. Okay? So that's an equation to represent this. Now, let's look at part B. What was the decrease in height of the pyramid? Great question. I think we can solve this from this equation that we wrote. So if we subtract 450 feet from each side, then we get 31 feet is equal to d. So that pyramid has shrunk 31 feet. Now I'd like to know how it shrunk. I don't know if this is like a settlement issue or what it might be, but it's very interesting. All right. That is all we have for today, and I will see you all next time, and we're going to solve more equations next time. If you like, click the like. If you haven't subscribed, please subscribe. See you next time.